In this presentation, we'll just go over the solutions to this second set of practice problems. Here in the first problem, we have two parentheses and we got a conclusion that the main operator is an arrow. So remember that whenever an arrow is the main operator, we're going to assume the left side is a PA. And then we're going to try to derive the right side, so we're looking to derive P. So we see P is right here. So how are we going to get to that? Well, we just need to eliminate our biconditional from one biconditional out. Now we just need to build the antecedent to get this, which we've got both the pieces that we need from 2 and 3 and in 2 and 3. Now we've got the antecedent. We can toss that into the conditional statement there to get P. So that's going to be from 4 and 5, arrow out. 4 and 5's 1, 2, and 3. And now we have the consequent that we are looking to get to. It depends upon our PAs, so we can arrow in from 3, which is our PA, consequence in 6. We're introducing an arrow. It's going to be 1 and 2 because the 3 will drop out once we do the arrow in there. So that is problem 1. So here on problem 2, our main operator is the ampersand. So we need to prove both sides, both conjuncts. And if we look, they both have tildes in front of them, and we look at our conclusion or at our premises, and we see that we don't have any of those in them. We don't have tilde s anywhere. We don't have tilde p. So we're gonna have to prove them separately and do tilde ends on them. So we'll start with the left conjunct, make a PA for it. Now we'll look to derive a contradiction, and actually, truth be told, I'm going to back up just for a second because we're going to end up using the same conditional statement for both of these. So let's do the conditional statement first. Let's do S or P, arrow T or Q. That's going to be from 1, double arrow out. This is the statement that we'll be chugging our PAs into as we get going. So might as well put it here in 3. Now I'll make my PA for S here at 4. Now we can see that I need to wedge in the P to get the antecedent that we see in 3. We'll toss that in there. We'll get T or Q. So that's going to be from 3 and 5, arrow out. 3 and 5 have 1 and 4. Now we just need to build a contradiction, and this is a contradiction to the statement in 2, so we'll put those together. From 2 and 6 and in 1, 2, and 4. Now we got a contradiction, depends upon our PA, so we can tilde in on our PA. So that's going to be 4, 7, tilde in. Then the 4 drops out. So there's one part. Now we just got to do the same exact thing, just with P. So that'll be a PA. Then we will wedge in our S from 9. Then we can toss that in to get our T or Q from 3 and 10. Arrow out. It's 1 and 9. Now we can build the same contradiction we had before. From 2 and 11 and in 1, 2, and 9. Got a PA, and it's or got a contradiction, and it depends upon the PA, so we can tilde in on the P. So it's going to be 9 and 12, tilde in, just 1 and 2 because the 9 will drop out, and then finally, just have to put them both together from 8 and 13 and in, and that will be 1 and 2. So that is problem number 2. Here in 3, our main operator is our arrow, so we're going to assume the left-hand side is a PA, and we'll look to derive the right-hand side, and we can see the right-hand side is right here, so we don't need to make a PA for T. We can just try to go get that from our actual premise. So let's break these things down. So the only way to make the first biconditional useful is to break it down like this. From 1, double arrow out. Because then we can wedge in our S to our Q in 3. Now with that, we can get our P from 4 and 5. Arrow out. So that's 1 and 3. And now we can make our other biconditional useful by getting that conditional out of it. Now we can toss the P into that to get tilde T. So that will be from, let's see, 6 and 7. Arrow out. 1, 2, and 3. Now we got to the consequent we were trying to get to. Depends upon our PA, so we can arrow in. PA is at 3. Consequent is at 8. Oops, sorry. 8. And we're doing arrow in. And then it'll be 1 and 2. And the 3 drops out. So that's problem 3. So now on 4, our main operator on conclusions, another arrow. So we're going to assume the left-hand side. It's a PA. And then we're going to look to try to derive the right-hand side, which is just the letter R. We see that it is here in our premise, so we don't need to assume its opposite. We should just try to go and get the R. So what are we going to do? Well, we can toss this P first into the regular conditional that we have in line 1. So that's going to be 1 and 4, arrow out. And 4. Now, to make use of the second biconditional, we can eliminate, or can write this version of the conditional from 2, double arrow out. Now we can toss our Q into this to get T and S from 5 and 6, arrow out. 1, 2, and 4. Now we are still in need of the antecedent to our conditional in line 3, so we'll move the S out from 7. And that can go in, oh, I should do this real quick. 1, 2, and 4. Now we can get the R from 3, which is our conditional statement. 8 is our antecedent. We're doing arrow out. So that's 1, 2, 3, and 4. And so here in line 10, we can build our conditional statement from our PA in 4 and our consequent in 9, doing arrow in, and then 4 drops out. Here in 5, our main, or our conclusion is just the letter R. So let's just see if we can derive it, because we see it in our proof, or at least in our premises over here. So maybe we don't need to assume its opposite and look for a contradiction. Maybe we can just derive it straight up. So I'm going to start by breaking up my conjunction here in 1. I'm going to break both of those pieces up. Now, what can I do with my biconditionals? Well, the 1 and 2, I can break it down into this conditional statement, and I already have the antecedent for this, so I can get S and T from 5 and 6, arrow out. 5 and 6, 1 and 2. Now, let's take stock of what we still need. So we're trying to get to R, which means we can break down our biconditional in 3. We probably know already that we need this conditional statement from it, because if we had R, we wouldn't have to use this conditional statement at all. So more than likely, gonna have to go this way. So how do we get this antecedent? Well, I can get the t from 7 and out, and I've already got the p in 4, so I can put those together. That will be from 4 and 9 and in. 4 and 9, that's 1 and 2, and then I can get R from 8 and 10, arrow out. And then I didn't need anything else. That was the conclusion I was looking for, so that's it. So moving on to 6, the main operator in our conclusion is this arrow, so that tells us immediately that we are going to assume the antecedent and look to derive the consequent. So what can we do here? Well, we can break up our tilde p and tilde s if we want, and it looks like we're gonna need to do it. Then we can get our biconditional out, and if we look, the tilde pt we can build. So let's do tilde p and t, arrow q, tilde s, arrow r. So that's going to be 1 double arrow out. Now let's build the antecedent for that. So we can put tilde p and t together from 2 and 4 and in, 2 and 4, or 2 and 3. Then we can get our q or tilde s, arrow r from 6 and 7, arrow out, 2 and 3. Now we can wedge in a q on our tilde s that we have in 5, and then we can get our r from 8 and 9, arrow out. That was the consequent that we were looking to get. Depends upon our PA, so we can arrow in from 3 and 10, arrow in, and that's going to be 1 and 2 because the 3 drops out after we do arrow in. Here on 7, our main operator in our conclusion is an arrow, so we know that we're assuming the left side, and we're going to look to derive the right side. Well, let's look at the right side. The right side's tilde t. Do we see that in either of the premises? We do not, but we do see a regular t without the tilde, so it's looking like we're going to have to assume the opposite of our consequent and look for a contradiction. So how are we going to get there? Well, first things first, we have this biconditional, and we can write out the conditional p or q, arrow t, arrow tilde r from 1 biconditional out. Now we can build this antecedent with our P from 3, wedge in, and with that, we can get our T arrow tilde R from 5 and 6, arrow out, 1 and 3. Now we can toss our T into this conditional statement in 7, so that's going to be from 4 and 7, arrow out, and we're looking to build a contradiction, which we can do with the R and tilde R from 2 and 8, and in 2, 3, and 4. Now, which one are we trying to add the tilde to? We're not trying to add the tilde to the P, we're trying to derive tilde T. So we're going to add our tilde to our T, and we are going to cite 4 is our PA, 9 is our contradiction, we're tilding in. That's 1, 2, and 3. The 4 associated with the T will drop out. I can write a 3 that looks legible. There we go. So now we've reached tilde T. Depends upon our PA that we made of P in line 3. And we consequent in line 10. We're introducing an arrow. That's going to be 1 and 2 because 3 drops out. So looking here at problem 8, our main operator is an arrow. So we are going to assume the left-hand side as a PA. And we're going to look to derive P and T. So we know we need to find P by itself, T by itself, and actually this one won't be too bad because all we got to do is eliminate this biconditional in 1 and eliminate this biconditional in 2. And now we can get P and T by just doing arrows out. So I'll do 3 and 4, arrow out, 3, and then I can get T, 3 and 5, arrow out, from 2 and 3, 3, 5, yep. Now we just gotta put them together, from 6 and 7. And then we can arrow in P and T from 3 and 8, arrow in. Then our 3 drops out, and that's problem 8. So here in 9, our main operator and our conclusion is an ampersand. So we need to prove each one of these sides independent of one another and then put them together. And since they are a conditional statement, we know that we need to assume P as a PA and then look to prove the consequent. We'll focus here on the left-hand side first, the left conjunct, and then we'll do the right conjunct. So, what can we do with P? Well, we can eliminate the biconditional in 1, and then we can take the P that we've got there, get the R out, so that's 3, 4, arrow out, 1 and 3. Then we can get the biconditional out here in 2, and we can toss our R into our conditional statement here in 6, so we can get T and S. It's going to be 5 and 6, arrow out. 5 and 6, that's 1, 2, and 3. Now, something that's sort of interesting, we can separate T and S here in 8 and 9 from 7 and out. I'm going to do both of them at the same time. I know we should only be looking for T right now, but it'll be alright. Because what we'll do is, actually, no, we'll stick with this. I think you guys can handle it. So we have our consequent, our T, and it depends upon our PAP, so we can do P arrow T from 3 and 8, arrow in. That will be 8, so 1 and 2, because the 3 drops out. Now, interesting enough, we have, looking at our right conjunct, we have derived our consequent, the S that we're looking for, and it depends upon our PA already, the same PA we would make for arrow in. So we can do PS from 3 and 9, arrow in, to drop out again, and then we just need to put them together in line 12, PT, and P arrow S from 10 and 11, ampersand in. Let's see if I can squeeze that in there. 10 and 11, ampersand in, and then 10 and 11 depend on 1 and 2. So this is a little bit of a little trick, but we still follow all of our rules the same, because our consequence we arrived from our PA, and it's the same PA in both instances. It's going to be a P, so we can just derive it like that. We don't have to do all the same stuff again. So that's problem 9. So here in 10, our conclusion is just the letter T. And if we look in our proof, we don't see the letter T anywhere, but we do see a tilde T. So our best chance moving forward would be to look for a contradiction in tilde in, because that is, or tilde out, because we at least have a tilde T. We could do something with what we have if we have the opposite of our conclusion. So let's assume tilde T is a PA, and then look to derive a contradiction. So let's separate out our ampersand in 2. And then now we need to break down our biconditional. Well, we can build S and not T, so let's break down the biconditional. So we have this. That's going to be from 1 biconditional out. And then we'll ampersand in our 2 conjuncts that we need from 3 and 5 and in 2 and 3. And we can get P and Q from 6 and 7, arrow out, 2 and 3. Now we're still looking for a contradiction. I have a tilde Q. If I get the Q out here in 9, so 8 ampersand out, then we can build our contradiction in 10. 4 and 9, ampersand in, 2 and 3. Now we got a contradiction, depends upon our PA, so we can tilde in on our T. And that is it. 3 drops out, so it's just 1 and 2. So that's problem 10.